Hi, so in this video we're going to be talking about our Lab4. So first we're going to be providing a brief overview of our code, followed by a demo of our clock, and finally a discussion about our successes and failures. Our current time module sets and shows the time on the FPGA. We have a lot of inputs and outputs that we had to consider. Going in order, for the inputs, there's the clock, which allows us to account for every second that passes. There's also set and mode, which indicate whether we should take in the current input of time and change the clock to that set time, or simply continue incrementing the values that we already have. There's also inputs that the user can put in when in the mode for setting up the time, with 2 digits for the hours, the minutes, and the seconds. Finally, the outputs are to display the time as the clock continues to run. If the current set and mode are 1, it will take in the inputted time as the new time that should be displayed. However, if these inputs are not 1, it will go through with the time that was already set and in increments. In these if-else statements, we're basically checking to see how the clock should be displayed as the clock is running. First, we check to see if 60 seconds have passed, as this means that a minute has passed. We have to account for the least significant digit of minutes when it's 9, as this would lead to it turning 0, and the greatest significant digit to add 1 when a second passes. If not, we can just add the 1 to the least significant digit of minutes. If 60 seconds haven't passed, we can just add the seconds to its own digits. We add 1 to the greatest significant digit of seconds when it's 9, and add 1 to the least significant digit when it's less than 9. We use the same logic as before when it comes to 60 minutes passing, as we check the digits of hours to make sure that it is a 24-hour clock. At the end, we also need to check to see if 24 hours have passed, as that is a threshold of a typical clock, and if it does, we reset the hours to 0.
So one snippet of code I found interesting was my set time module. So I have the clock going in, the inputs for the different switches, the next button to designate which digit will be edited, the mode from the alarm clock, and then the outputs for set. I have a state machine in here which designates which digit is being edited at the time based on the state the state machine is in. And then at every time the clock goes high, if the mode is equal to the set time mode, then it checks the next button and decrements the state starting at the highest digit of hours. Else, it sets them to default values, so state just becomes the last digit of hours and all the outputs become 0. That way, if you're not in the state, then it just sets the values to 0 and nothing changes while you're not in the state. And then I have a case statement for each of my states. So they just get set from the inputs of the switches based on whatever the state's in. And then finally, I assign the outputs based on whether or not the mode is in set time mode. If it's not in set time mode, it gets set to 0, and if it is, it gets set to the register values. And then those outputs get fed into current time in here. So then I check in current time if the mode is set time and the set goes high. Then instead of incrementing the clock, I simply just set the clock to whatever the set time value was. All right, so here's our demo. Right now we are in 20 hours and 40 minutes. So if I switch to 12-hour time with the top button, then it goes to 8:40 p.m., which is the correct time. I can switch the mode with the middle button to set time mode. And so if I switch the buttons on the right, then I switch the digit that I'm editing, and using the next button, I can switch which digit I'm editing, starting from the leftmost hours. So I want to set to 11:30. I use the switch on the left to set the time. Now it's an 11:30 a.m. Note that it was 24-hour time when I set. And so the bottom button here, just a little demo, will toggle an LED, which designates whether or not your alarm is toggled on or off. So now I'm in alarm set mode. I can set it to, so we're at 11:30 a.m. right now, I can set it to 11:31. And if I do that, using the set switch here, and I go back to my mode, note that I did not toggle the alarm on. So once we get to 11:31, we will not see the alarm trigger. Note that the alarm triggers with the rightmost LED, so it'll blink for 10 seconds when the alarm goes off. And note that the LED on the left is not on, indicating the alarm is not on. So as you can see, the LED does not turn on the right. Now I can set my alarm to 11:31, 30 seconds. I use the set switch to set it. And then I toggle my alarm on with LED on the left. And you'll see that the LED switch is on and off on the right until for about 10 seconds. So the main successes of our design would be implementing a good set time and set alarm mode, as those work properly as they should. Set alarm saves the alarm that you set it to when you switch back to that mode. And also the current time module is implemented properly. So not only does it function as it should and change the hours, minutes, and seconds when it should, but also does keep pretty accurate time from what I tested.
So one of the failures of our lab was the fact that we weren't able to fully incorporate our carry select adders into our modules for our clock. Instead, we had to use behavioral Verilog to increment values, and this was just due to the fact that we didn't think of incorporating sequential logic beforehand when dealing with these modules. So basically, it would have just taken way too much time for us to incorporate our carry select adders, and due to the time frame that we were given, we decided it would be best to focus on more important things first and worry about the functionality of our clock. And in the future, if we had more time, we would have definitely incorporated more of our ALU into how we dealt with our modules. And yeah, thank you so much for watching.